Hi everyone and welcome back to another video. In the last series of videos, we have discussed the first chapter Real Number Class 10 CBSE. In this video, we are starting new chapter, the second chapter, that is Polynomials. You have already studied about polynomial in 9th class. You know the standard form. You know what is the order of polynomial, what are the coefficients, what is a variable in a polynomial, all that you know very well. But before starting the chapter, let's have a look into that. Okay? F of x equal to an x raised to n plus an minus 1 and x raised to n minus 1 plus etc. up to a1x plus a0. This is the basic form you may studied or you may have seen in your textbook. By looking this expression, you no need to worry. The fact is more simple than what you are expecting. Okay, here an minus 1 up to a1 a0, these all called coefficient of the polynomial. See, a1 a2 a3 a4 like that up to an, these are called a coefficient of the polynomial. Okay, these coefficients are always a real number. All the coefficients are real number. This you must remember. All the coefficients are always real number. Next one, n be a non-negative integer. What is n? In this expression, the exponent of the variable, that is called a n. This n will be always a non-negative integer, which means in integers, you know, there are negative integers, positive integers and 0. But from that, negative integers you cannot take. You can take only the positive integers and 0. These values an minus 1, a1, a0, like that, the values which are taking place with the variable, those values you can call coefficients. In this case, the variable is x. So while naming the polynomial, what I did here, some letters, it can be f, p, whatever. Sometimes you are seeing p of x, f of x, q of x. You can make any naming, but the variable inside the bracket must be the same what you are seeing here. Okay, so this is a polynomial f of x in variable x. Now let's look into certain examples. We want to check whether the given algebraic expressions are polynomial or not. So as I mentioned before, there are two conditions. First one, the coefficients must be real number. Second one, that the exponents of the given expression, must be a non-negative integer. If these two conditions satisfy, then the given expression is a polynomial. Okay, let's look into the first case, 3x plus 1 by 2. First, we must look into the coefficients. Look here, two terms are there. First one 3x and second one 1 by 2. 1 by 2 does not have any variable, so we can call this one as constant term. How you can understand the terms? The terms in expression is always separated by plus or minus. The terms are always separated by plus or minus. So here you can see 1 plus. So two terms you can find from here. Okay, so 3x plus 1 by 2. Now let's check it. Look into the first coefficient here. This is 3. 3 is a real number. You know, 3 is a real number. So first condition is okay. The coefficient of the term is a real number. Okay, so you got it. It's a real number. The first condition, okay. Second one is about the exponent of the variable. Look, what is the exponent here? It is simply x, which means x raised to 1. So here exponent is 1. So 1 is a positive integer, right? 1 is a positive integer. So here both the conditions are satisfied. First one, the coefficient is a real number. Okay. Then second one, the exponent is a positive integer. So both are satisfied. So we can call this one as a polynomial. This one is a polynomial. Look at the second one. Here first, How many terms are there? There are 3 terms because one plus sign is there and another minus sign is there. So in between those signs there are 1, 2, 3. 3 terms are there, right? In these 3 terms, let's look into the coefficients first. The first coefficient, that is 2. 2 is a real number. Second one, minus 3 by 2. It is also a real number. Then last one, it is a constant term. You don't need to worry about it. Okay. Now, these 2 coefficients are real numbers. So first condition, coefficients are real number. Now about the exponent. Exponents here, first case, the power is 2, and here in the second case the power is 1. 1 and 2 both are positive integers. Condition satisfied. So this is also a polynomial. Now look into the third one. Here 1, 2, 3, 4. There are 4 terms. So in these 4 terms the coefficients are 5, minus 3, and here no values are there, so which means 1 is there, right? So 1, and here this is the constant term. Now look at the coefficients. First coefficient 5, that is a real number. Second one is also a real number. Third one is also real number. So all these are real numbers. Coefficients are real numbers. Okay. Now about the exponents. Here first exponent 3 and second one is 2 and third one here the exponent is 1. Right. So all the exponents are positive integers. So this is also a polynomial. Next one, root 2. Root 2 is also a real number because in the 9th class syllabus you are coming across that. All the irrational numbers are also a real numbers, right? So this is a real number. This is the one and only coefficient here. So coefficient is a real number. Now about the exponent. Exponent, here exponent is 2. So that is also a positive integer. This case also it is a polynomial. R of x equal to under root of 2x. Here 2x is inside the root, square root. Now second term, that is 2x square. Okay, look at the second one. Here the coefficient is a real number. Okay, that is 2. Now about the x square exponent, that is positive integer. Okay, no worry, this is fine. Look at this, root of 2x, square root of 2x. In this case, look at square root of 2x, square root of 2x. You can write this one as 2x all raised to 1 by 2. Here is the problem. Here, this case, 2 raised to 1 by 2, x raised to 1 by 2. Look at the power of x. The power of x is 1 by 2. The power of x is 1 by 2. I have already mentioned that exponent of the variable cannot be a fraction. It cannot be fraction, it cannot be decimal number. It has only one choice, that is a non-negative integer. It can be only a non-negative integer. Okay. So in this case, here the power is a fraction. So we can say that it is not a polynomial. G of x equal to 2 over x plus 7. Here in this case, 2 over x. You can carry this x to numerator, then it will become 2x raised to minus 1. Positive power turns to negative while you are moving from denominator to numerator or numerator to denominator. So in this case, when I took this x to numerator, then it become 2x raised to minus 1 plus 7. Look at the exponent here. That is a negative integer. The exponent of the variable cannot be a negative integer. So we can conclude that it is not a polynomial. Okay. So from these examples you can understand 2 things. That is, first one, if the variable is inside the square root, then that is not a polynomial. Second thing, if the variable is in the denominator, then that is not a polynomial. Before moving to next topic, let's discuss about the degree of the polynomial. Degree. What do you mean by degree of the polynomial? Okay, so let's look into these 4 cases. In these 4 cases, you could find that in the first case, exponent is 1. Okay, there is only one variable here, that is x raised to 1. then the highest power of this expression is called a degree. So degree of this polynomial, degree of f of x in this case is 1. Now look at the second expression. There are two different terms with y. These two terms contain y as the variable. Now look at the exponents. Look at the power of the given two variables. Here the power are 2 and 1. Now out of these the highest power is called a degree. So 2 and 1, which is the highest one? 2. So we can say that in this case degree of the polynomial is 2. Third case, now 1, 2, 3. There are 3 different terms with x. Now look at the power of each one. First one power is 3, second one power is 2, and third one power is 1. Out of this, the highest power. The highest power, that is clearly 3. So that is 3 degree of the first topic, zeros of a polynomial. Let's consider a polynomial that is 2x minus 2. Look at this polynomial. Let me name it as p of x. P of x is equal to 2x minus 2. See, in this polynomial, in the place of x, you can substitute any values. Any real number you can put there. Let me put here 2. Look at this. 2 into 2 minus 2. 4 minus 2, that is 2. Afterwards, let me put here 0. Look, then wherever you see x, there you can place 0. Then it becomes 2 times of 0 minus 2, that is 0 minus 2 minus 2. So you got p of 0 is equal to minus 2. So these are called the values of a polynomial. You can evaluate the polynomial for any given value. Okay. Now in this place of 2 or 0, instead of that you can substitute here 1. Now let's see what happened. 2 times of 1 minus 2, look, 2 times of 1, that is 2, 2 minus 2, 2 minus 2 is 0. See here 0, we obtain 0. While we are substituting 1 here, we obtained 0. The value of the entire polynomial became 0 while we are substituting 1 in the polynomial. Then this 1 we can call 0 of this polynomial. For what value? The value of the polynomial becoming 0, then that value you can call 0 of the polynomial. 0 of the polynomial. But for finding zeros here, what we did, we tried different values. With different values, we substituted in the polynomial and calculate the values. When we got 0, that value we considered as zeros of the polynomial. But it is not practically possible. Sometimes you want to try many different values. Okay, so practically it is going to consume your time, right? So then let's consider the same one, right? P of x. This p of x is equal to 0. That is the meaning of 0 of the polynomial. For some values of this x, this polynomial value is going to be 0. So we must find for what value this polynomial is becoming 0. So for finding that, p of x, what is p of x? 2x minus 2. Let's equate this 2x minus 2 equal to 0. Now 2x is equal to 2. X is equal to 2 by 2, that is equal to 1. X equal to 1. See, we obtain the same value in this case. So for finding the zeros of the polynomial, just want to equate the polynomial with a 0. Then solve for x, then what the value what you are obtained, that you can call 0 of that polynomial. Let's take another example. 2x minus 1 by 2 equal to 0. Let's solve for that. 2x is equal to 1 by 2. Now take the 2 that side, x is equal to 1 by 4. Which means if you substitute this 1 by 4 in this polynomial, you are going to get 0. Let's check it. Let's take this value 2 into, instead of x, substitute 1 by 4. 1 by 4, minus 1 by 2 is equal to 0. That get cancelled 2. Now 1 by 2 minus 1 by 2, that is equal to 0. Now let's look into the geometrical meaning of zeros of a polynomial. Okay, for that I consider a polynomial here, f of x equal to x square minus 4. Okay, so let's find this zeros of this polynomial. X square minus 4 is equal to 0, then x square is equal to 4. So x is equal to root 4, root of 4. So up to last year you consider root of 4 is 2. From this year onwards we are considering that is plus or minus 2. Which means x has two values, x is equal to 2 or x is equal to minus 2. Is it correct or not? Let's check. 2 square, what is the square of 2? That is 4, right? Minus 2, square of minus 2, that is also 4. Okay, we can make detailed discussion on this plus or minus on quadratic equation chapter. Okay, so here we got two zeros, x equal to 2 and x equal to minus 2. Let's check it correct or not. Let's substitute here 2 square 4, 4 minus 4 0, minus 2 square, that is also 4 minus 4, that is 0. Okay, so this 2 and minus 2, these are the value. For that the value of the polynomial is going to be 0. So we can call 2 and minus 2 are the zeros of the polynomial. Okay, now this one we are going to represent geometrically. For that we can draw the graph of this. For plotting the graph of that, let me convert this one into two variable form first of all, right? What is f of x actually? F of x means for different value of x, what you are getting output, that is called f of x, right? You can put here different values of that. For example, here if I put 1, if I put here 2, then 2 square minus 4, that is 0, which means f of x is equal to 0. It will come on y axis, right? If I put here 1 square, that is 1 minus 4, minus 3, that minus 3 is going to come on y axis. So f of x is always equal to y. So instead of f of x, let me write here y is equal to x square minus 4. So this is y is equal to x square minus 4. Now we can move to graphical representation. Let's put the value of x here. So let me put here 1. If I put here 1 square 1 minus 4, that is minus 3. Now minus 1, let me consider minus 1. Minus 1, if I put here minus 1 square, x value is minus 1. Minus 1 square is 1. 1 minus 4, that is again minus 3. Now let's plot the graph of this equation. Okay, so we have the Cartesian plane here. So here first value x value 1 and y value minus 3. Okay, on x axis 1, at that time y axis minus 3, y axis minus 3. So this will be the point. Now second value, that is minus 1 and minus 3. So minus 1 x axis, minus 3 on the y axis. This is the point. So we got 2 points here. First one 1 comma minus 3, second one minus 1 comma minus 3. So we got 2 points. Okay, let me consider one more point here. Okay, that is x2 at that time y value is coming, just put here 2 square 4 minus 4, that is 0. X is minus 2, that moment this is again 0. So let's consider these 2 points. X is 2, here it is, x is 2, okay, and y is 0. So x is 2 and y is 0. So this is the point. Okay, that means 2 comma 0. Here similarly this is minus 2 comma 0. So you got here 2 points. Let me join this point. Look here, this value, this graph is going to be like this. Now let's extend this expression, right? Look at the graph. On this graph, you could see there that graph intersecting the x-axis two places exactly that graph is intersecting. The first point, that is -2, and second point is 2. So the values were at the graph is intersecting the x-axis that are called a polynomial of this polynomial f of x. Take another examples. We have a graph like this. Look at this. This is a function called g of x. On this g of x, look, 1, 2, 3, 4. 4 places the graph is intersecting the x-axis. Then we can say that we can call these 4 points as the zeros. Here 4 zeros are there. 4 zeros. Another example. Here, look, in this graph, two positions, this is x-axis and this is y-axis, at two different positions the graph is intersecting the x-axis. So the values at which the graph is intersecting the x-axis, those values are called zeros of the polynomial. Now the polynomial, look here, everywhere the polynomial we are considering in the terms of x. So if the polynomial is in the terms of x, then you must see how many intersections are there in the x-axis. Okay, suppose the polynomial is in the terms of y. For example, f of y is equal to 2y. Look, here the polynomial is in the terms of y. Then what you must do? You must look for the intersection on the y-axis. You must see there in y-axis how many intersections are there. Usually in our syllabus we are coming up across intersection with the x-axis. All the polynomial will be in the terms of x usually. Okay, so in such cases you must see how many intersections are there in the graph with the x-axis. The number of intersections on the x-axis, that is called that is equal to the number of zeros of the polynomial. So this is the geometrical meaning. Let's watch its continuation in the next video. Until we meet again with another video. Bye.